Greetings and welcome to my channel. I'm Mr. D. In our last episode, we discussed writing chemical formulas from the names of the compounds. In this episode, we'll look at doing the reverse of this. We'll take the chemical formulas and determine the compounds' names. As in the previous episode, we'll be working with binary ionic compounds, ternary ionic compounds, and binary covalent compounds. To assist you with this, I've placed links in the description below for a periodic table and a list of common ions that you can download and print out. I strongly recommend that you memorize the ions, as this will simplify the process of naming the compounds. Alright, let's just jump right in. As you may recall, binary ionic compounds are composed of a metal bonded to a nonmetal. So you'll name the metallic half of the compound, then the nonmetallic half. Keep in mind that some of the metals can form more than one type of ion. When we come across those metals, we're going to have to do a little simple math. I'll show you what I mean by this when we get to some of those examples in the following. So for our first example here, we have AgCl. Ag is silver. Cl is the chloride ion. So silver chloride. For our next example, we get K, which is potassium. And O, which is the oxide ion, so potassium oxide. Okay, for our next one, Ba is barium. H is hydrogen, so barium hydride. Remember, we're dropping the ending and adding IDE, so instead of hydrogen, it's hydride. Our next one, Al is aluminum. And Br is bromide. Okay, our next one here, we have magnesium. This is the nitrogen atom, so we're changing the ending to IDE, so magnesium nitride. Now this next one here, this is one of those ions that has multiple charges, so we're going to have to figure out which charges it's going to be. So Pb is lead. We're going to hold off on putting in the Roman numeral until we figure it out. The O is the oxide ion. Alright, so the lead is the one we're trying to solve for. The oxide ion has a 2- charge on it. The total charge is 0. So when we add up the charges on each of the ions, the total charge has to equal 0. So the charge of the lead plus the charge on the oxide ion, it gives me a total charge of 0, because remember, compounds have no charge. So x plus -2 equals 0. So that means that x equals +2. So this is lead 2 oxide. Okay, our next one here is another one that has multiple ions. So we'll come back to the charge in a second. So this is copper. S is the sulfide ion. Copper we don't know. Sulfide is a 2-. So we have 2 copper ions that we don't know the charge on. I'm going to add that to the sulfide ion, which was a -2. And we don't know, and the total charge is going to be 0. Total charge on any compound is 0. So when we add up our charges, it has to equal 0. So 2x plus -2 equals 0. So that means 2x is equal to a -2. So that means that x is equal to -1. Excuse me, +1, my apologies. So this is copper 1 sulfide. Here we have mercury. Again, another one that has multiple oxidation states or multiple charges. And this is the phosphide ion. There are 3 mercuries that we don't know the charge on, because we have to figure it out which one it is. We're going to add that to the charge on the phosphide. There are 2 phosphide ions, each of which has a charge of -3. And when we add up all the charges, it has to equal 0. So we have 3x plus -6 equals 0. 3x equals +6. So that means that x equals a +2. So this is mercury 2. Whoops, I'm sorry. Roman numerals, Dufresne. This is mercury 2 phosphide. Okay, let's move on to the ternary ionic compounds. As a reminder, these are metals bonded to a polyatomic ion. So you name the metal, then you name the polyatomic ion. Alright, so here's our first ternary compound. K is potassium, so we've named the positive half already. So everything that's left is our negative half. So this is going to be a ternary compound. The negative half is this polyatomic ion here. But if you've memorized, you'll see it's permanganate. Potassium permanganate. So we have the zinc ion, and this is our polyatomic ion, the chlorite ion. Now, just as a reminder, for the ionic compounds, we don't need any kind of prefixes. Don't have this. It could be called like dichlorite. For the ionic compounds, we get the subscript from the compound itself. So we don't have to worry about trying to figure out what we're going to end up needing, so we don't need any prefixes. The only thing you need prefixes on are going to be the covalent compounds. Alright, so for our next one here, Li is lithium. So we've named the positive half, the metal. So everything we have left is going to be our polyatomic ion. So this is the polyatomic ion, hydrogen sulfate. Ca, calcium. So we've named our positive half, we've named our metal. This inside the parentheses is the acetate ion. So calcium acetate. Alright, so our next one has chromium ion, which has multiple charges, so we're not sure which one it is. So it's chromium, and leave open parentheses. CO3 is the carbonate ion. So there are 2 chromium ions, which we don't know the charge of. There are 3 of the CO3s, 3 carbonate ions. Charge on carbonate is a 2-. The whole thing has to equal 0. So we have 2x plus a -6 is equal to 0. 2x is equal to a +6, so x is equal to a +3. So chromium 3 carbonate. Next one we have Fe is iron. Again, multiple charges, so we have to figure out which one it is. PO4 is phosphate. There are 3 of the irons that we don't know the charge on. There's 1 of the PO4s. PO4 phosphate ion is a 3- charge. Whole thing equals 0. So 3x is equal to a +3. So x is equal to a +1. So iron 1 phosphate. Pb is lead. It's one of the ones with multiple charge. IO3 is the iodate ion. So we have the charge of lead. We have 4 of the iodate ions, which is a 1 minus. The whole thing equals 0. So X is equal to a positive 4. So this is lead 4 iodate. We have Sn, which is tin. Multiple charges, so we got the parentheses. Cr2O7, this polyatomic ion, is the dichromate ion. Tin we don't know the charge on, so it's X. Dichromate is a negative 2. The whole thing has to equal 0. So X is equal to a positive 2. So this is tin 2 dichromate. Alright, that takes care of the ionic compounds. Now let's turn to the binary covalent compounds. These will be compounds composed of a nonmetal bonded to a nonmetal or a metalloid. Here we'll need those prefixes that are on the second page of the ion sheet. Like the ions, I urge you to memorize these prefixes. As a reminder, the first element only gets a prefix if there are 2 more atoms, and the second element always gets a prefix. The ending of the second element's name is dropped, and IDE is added in its place. Alright, well, here we go. Our first 2 have common names. It's ammonia and water, but let's look at them in terms of using our naming system. So the first element is nitrogen. There's just 1 atom. Since there's only 1 atom, there's no prefix on it, so it's nitrogen. The second element always gets a prefix. There's 3 hydrogens. The prefix for 3 is tri. And we're dropping the ending of hydrogen and adding IDE. So trihydride. Nitrogen trihydride. Our next one, we have 2 hydrogens. Prefix for 2 is di. So dihydrogen. There's 1 oxygen. Prefix for 1 is mono. Since oxygen starts with an O, we're going to just drop 1 of them. So it'd be monoxide instead of monoxide. Our next one here, 1 carbon. Again, the first element doesn't get a prefix. This is just 1 atom. So carbon. 1 oxygen. So monoxide, like in the previous example. Oops. Okay, so our next example, 2 nitrogens. So di-nitrogen. 3 oxides. The prefix for 3 is tri. So trioxide. There's 1 silicon. So it's just simply silicon. The prefix for 4 is tetra, not quadra. Tetra. Fluoride. Okay, our last couple of examples here. We got sulfur, 1 atom, so no prefix. 3 oxygens, trioxide. Last example, 2 sulfurs, so disulfur. Remember, for the first element, you're not changing the end of its name. It's always the element's name. The second element is the one you're changing. So 2 fluorines, so difluoride. Well, there you go. Hope you found that to be rather painless. Biographical endnote. Henry Cavendish was an English chemist and physicist. He was born in 1731 to an English mother who was staying in Nice, France for her health. Unfortunately, this wasn't much help to her, and she died when he was only 2. He was educated in England and eventually completed 4 years at Cambridge, but he didn't get his degree because he refused to participate in the required religious exercises. Also, due to a lifelong difficulty with facing people, he also felt he wouldn't be able to face his professors for his exams. Cavendish was extremely shy and absent-minded. When he spoke, which he only did on rare occasions, he spoke with a stammer. When absolutely necessary, he might exchange a few words with a man, but he would never speak to a woman. He in fact feared women to the point that he couldn't even look at them, and he communicated with his female servants by note. Should he cross paths with one of his female servants, she would be fired on the spot. Although it's eccentric, he did have one true love, and that was scientific research, which he devoted 60 years of his life to. He didn't care if his work was published or if he received credit for his discoveries. All he was concerned about was satisfying his own curiosity. What he learned about electricity wouldn't be discovered by others for another half-century, setting back scientific progress by who knows how many years due to his secrecy. In 1766, he communicated to the Royal Society some early research he had done on a gas that he had derived by reacting acids with metals. This gas turned out to be hydrogen. Although others had researched it as well, he was the first to study its properties systematically and was thereby earning the credit as hydrogen's discoverer. The gas was named thus by Lavoisier 20 years later. In 1784, he showed that by reacting hydrogen with oxygen, you could produce water, thereby dispelling for all time the old Greek idea that water was a fundamental element. Thank you for watching my video. I hope you found it both informative and interesting. If you did, please smash that like button below and consider subscribing and hitting the notification bell so that you know when my next video comes out. When it does, please join me again. Until then, be good, be careful, and don't trust atoms. They make up things.